Eccoci ritornati, sono felice adesso di presentare il nuovo relatore. Questa nuova sessione sarà in lingua inglese, per cui ho il piacere di presentarvi Anahit Pogosova. Nice to have you here, Anahit. I present you to our participants of the Cloud Conference, and if you are ready, if you want to share something, you can share using the button down in our portal. Otherwise, I just here your content. Okay, now your content is up and running, and the stage is all yours. Thank you again to be here with us. Thank you.
Thank you for having me. And hi everyone, I'm Anahit, and welcome to my kitchen here in Finland. And I'm going to be talking today about serverless data streaming at the scale. So first there's going to be a short introduction. Then we'll look at AWS services we have used and go in some details. And finally, I will wrap up with some gotchas and lessons we have learned along the way. So shortly about me, I am a lead cloud software engineer at a company called Solita. I'm also an AWS Community Builder, which is a program for AWS enthusiasts and active community members. And for the past 3 years, I've been a part of data and AI team at Finland's national public broadcasting company, YLE. And you can think of YLE as an analog of BBC in Finland. It provides broadcasting, radio, and streaming services to entire Finnish population. It also has no advertisement anywhere, and it's paid from taxpayers' money. And it's very highly respected here in Finland, with some bold missions of strengthening Finnish society and culture and preserving and expanding content in Finnish language. So as I said, YLE has a streaming service. It's called YLE Arena, and it's not just a streaming service, it's the biggest streaming service in Finland. And not only that, it's actually the only streaming service in the world that is bigger in its region than Netflix. So YLE Arena has more audience in Finland than Netflix does, and no other service in the world can say that. And our data team is responsible for example, Arena recommendations engine, and also for image personalization, which is we don't only personalize the content that you are going to see, but we also want to personalize the way you are going to see the content. So for example, we are going to have several cover images for the same content, and we'll show you the one that we think appeals to you the most based on the information that we know about you. And I'll be talking about it in a bit more detail shortly. So as a data team, we are dealing with data. And by data, I mean mostly user interaction data. And it's nothing more than just JSON with the information about that interaction that we want to know. And why do we actually care about the data? Well, I told you we don't have any advertisements, any cash flow from that. So instead, we want to understand the customers better, and we also want to provide even better services for everybody. So let's talk some numbers. How much data are we actually talking about? Well, it's roughly 500 million requests per day, and one request is one user interaction. And it goes up and down during the day, and it reaches its peak around the prime time when it's roughly 600,000 requests per minute. And all that data ends up forming roughly 0.5 terabyte of data per day, and it's stored in JSON and Apache Parquet formats. So in addition to these daily variations, we might have some spikes in incoming requests. For example, when something happens in the world and people want to know the news, they go to the YLE services to read what's happening, and we might get a sudden spike in the amount of requests. And then there's also some predictable spikes when there are, for example, some sports events. Like this particular one was last spring when we had the Finnish parliamentary elections result night, which coincided with Women's Hockey World Championship finals, and Finland was playing. And if there's one thing you need to know about Finland, they love hockey here. So everybody who wasn't watching the elections, they were actually watching the hockey. So that night we got something like 2.5 million requests per minute, and it was quite a stress test for our system and for my nurse in particular, because I was on call that night. But enough of introduction, let's dive into the technical details now. So YLE uses AWS as its cloud provider. And here you can see a very high-level overview of our data architecture. And right away, I will say, don't worry, we will not go into all the details. We don't have enough time for that. But instead, I will try to tell you about our serverless data streaming part that I promised to tell you about. But first, let's see what were our high-level goals when we were building that pipeline. So we can probably summarize them in two goals. First, we wanted to load the data reliably into a data lake in a columnar format. And secondly, we wanted to enable different kinds of content personalization and near real-time analytics, like the one I told you about, where we want to personalize the cover images of the videos we show to you. So then why serverless? Well, nobody says it's better than Dr. Werner Vogels, CTO of Amazon, who is a man of many, many great quotes, but this one being, no server is easier to manage than no server. And well, I can't really disagree with that one. So let's have a closer look at our serverless pipeline. So all the requests from all around Finland come to our component called Analytics Collector. And here right away, if you're familiar with AWS services, you will say, stop, there is the Fargate, and it's not serverless. And I kind of agree with you, but only partly, because Fargate is the most serverless way in AWS how you can deploy your containers. So you just drop your Docker container, you specify how much CPU and memory you want, the auto-scaling rules, and Fargate takes care of the rest. So it's pretty close. But I'm not going to be talking about Fargate here. I will just mention that our analytics collector gets all the incoming requests, it does some filtering to them, then it batches them and sends them forward to a stream. And as a stream, we are using a service called Kinesis Data Streams. And what it is, it's a fully managed and massively scalable service to stream your data on AWS. After you write the data to the stream, it is available within milliseconds, and it's stored there for 24 hours and up to 7 days in case you need to replay it later. And to consume the data from the stream, you need to create some custom stream consumers, and there are plenty of ways to do that, but we are personally using AWS Lambda function as our Kinesis stream consumer, and I will be talking about it shortly. So finally, how is the Kinesis stream actually scaling? Well, it uses a concept called shard, and you can think of a shard as a unit of parallelism in the stream and as a first in, first out queue. So it's an ordered queue, and a stream is a combination of such queues. And each shard has a limited throughput. It can intake 1 megabyte per second or 1,000 records per second. So if you have more data, you just need to add more shards. And if you remember, I mentioned that during the evening times, we have roughly 600,000 requests per minute. So if we make an assumption that those requests come in uniformly, this will end up being something like 10,000 requests per second. And with 1,000 record limit per shard, it will mean we will need something like 10 shards to accommodate all that data. Well, reality is we actually have over 40 shards open at all times. And the reason for that is those spikes in incoming traffic that I told you about. So we don't want to lose the valuable data when something unexpected happens. So we basically end up over-provisioning our stream. And again, you might think that what's the problem with that? You can just throw as much shards as you want to a stream and be happy. Well, of course, there's a catch. In addition for paying for the data being streamed, with Kinesis streams, you also pay for each shard that is open. So it's always a balancing game between how many shards you want to have open. So how do you write the data to a stream? Well, there are plenty of ways. There are some direct service integrations where you don't even have to write any code at all. But we are using the most flexible one and the one that allows full control when you write your data. And it's the AWS SDK, or basically Kinesis API. And from now on, all my examples will be for Node.js SDK, but really all the considerations they hold for all the SDKs, so all the other languages as well. So with Kinesis API, you basically have two ways to write data to a stream. You can either write a single record, or you can write a batch of records. And it's always recommended to write records in batches because you save on API calls, you have less latency, you use less network throughput, you send less boilerplate payload back and forth to the network. It's always recommended to use batches. And when you send a batch, you just provide the name of the stream you want to send the data to, and then you have your array of records that you send. And each record contains your data payload that you want to write to the stream, and it also contains a string called partition key. And what a partition key is the way how Kinesis stream decides which shard to write your data to. So when you write a record to a stream, Kinesis calculates a hash value of that partition key, and each shard in the stream is assigned a range of hash values, and those ranges don't overlap. So your record will end up, based on that partition key, will end up in one and exactly one shard when it's returned to the stream. So it's recommended to use as random of a partition key as possible because you want to distribute your records evenly through your stream. You don't want to overheat a single shard. And in our case, we use the surrogate user ID as a partition key. Well, A, because it's random enough, and B, because we want the events of the same user to be ordered in our stream. So we want to get the event of user starting to watch a video before we get the event of user pausing the video, for example. And if you remember, I said that each shard is like an ordered queue. So the events there are in order. So by writing the events of the same user to the same shard, we achieve ordering of the events of the same user, basically. So we wrote our data to the Kinesis stream. What's next? If you recall, I told you that we have a Lambda function that consumes that events from the stream. And what Lambda does, it reduces a lot of heavy lifting. It takes care of a lot of things for you. It takes care, for example, of keeping track where exactly in that stream you are and where exactly in each shard you are when you're reading at any given moment. So it helps you a lot. But of course, you need to know how exactly it works, so you will use it correctly. And by default, one Lambda function is invoked once per second. It reads batches of records from a single shard, and you will have as many parallel Lambda executions or Lambda functions as you have shards in your stream. Unless you configure a thing called parallelization factor, if you want to increase the speed of the processing speed of your stream, you just throw more Lambda functions at every single shard. So you can have up to 10 Lambda functions reading from the same shard at the same time. So this will mean that you will have up to 10 times as many concurrent Lambdas reading from that stream as you have shards. And there's a very important point here to remember, and that's Lambda concurrency limit. You probably are aware that Lambda has a limit of how many concurrent executions it can have in each account, each region. And by default, it's 1,000. So there can be 1,000 concurrent Lambdas executions in one account, one region. So imagine you have a stream with 100 shards, which is not uncommon. It's a normal size stream. And you have a parallelization factor of 10. This will mean that you will have 1,000 Lambda functions just reading from your stream at all times. And it will probably fine. You won't have any problems until somebody else in your organization, in your region, in your account, decides to write another probably very business critical Lambda that does something very important, and that Lambda starts to fail for unknown reasons. And well, the reason is that your Lambda that is reading from your stream has consumed the entire Lambda budget. So it's a limit that has a very wide blast radius. It can influence or impact all the other systems in the same account and the same region. So you have to be very careful and keep a close eye on that one. And speaking about things you need to keep a close eye on, what happens if there is a problem? If, for example, there was about one bad record in your stream. So Lambda pulls your shard once per second by default. It gets a batch of records from that shard and it tries to process them. And if there was a bad record, the processing fails and the entire batch is returned back to the stream. And Lambda has some inbuilt retry functionality, so it will retry to process that one batch over and over again until it either succeeds or until the data in that batch expires. And if you remember, I told you that the data in Kinesis stream is stored for 24 hours by default. So Lambda by default will be retrying and retrying for 24 hours. And then after 24 hours, the data will finally expire and the entire batch will be dismissed. So you will lose not just that one bad record, you will lose the entire batch that you were trying to process. But that's not actually all. The bad things don't stop there, they actually start there. And the problem is that until Lambda tries to reprocess that bad batch, it doesn't read any other batches from that same shard. So all the other shards keep on with their lives, everything goes normally, data goes in and out, but that one shard is stuck because Lambda is retrying. And pretty much because of having one bad record, your entire shard can be stuck for 24 hours. And that's why it's called a poison pill situation. Like one record poisoned your entire shard. And after 24 hours, when that batch is finally discarded, your stream or your shard is probably filled with records that were written around the same time that previous batch. So they expire around the same time, and your Lambda won't even have time to process that data. So it will end up lagging. You will end up losing more and more data from that stream because it will expire, and Lambda won't have time to process it. So very important thing to keep in mind. And luckily nowadays there are ways to customize this error handling situation. So you can now specify the number of attempts you want Lambda to try to reprocess that bad batch and maximum age of the records. You can even split the batch recursively and let Lambda send its separate parts separately, and in the end, hopefully end up with just one, all the records being sent and just one bad record being dropped. So many options which you need to be aware of when working with Lambda and Kinesis. So let's return for a moment to our high-level agenda. We wanted, first and foremost, to load our data to a data lake in a columnar format. So far, we got our incoming requests, we patched them, we send them to a stream, and then there is our Lambda function that is consuming the data from that stream. And our Lambda function is called router Lambda, and what it does, it basically routes different events to different destinations. The thing is that we have inherently different events coming to that stream. So, for example, events from reading an article on our Wiley pages and from watching a video are inherently different in structure. So we want to separate all those different events to different places right away. And that's what our router Lambda does. It reads from the stream and separates and sends the events further to different destinations. And here comes the second service in AWS Kinesis family, and it's called Kinesis Firehose. And it's also a fully managed service, but this one is meant for loading your streaming data to a destination. And there are plenty of options for destination, but S3 is what is important for us in this context. So Firehose can load streaming data to your destination to S3, for example, with pretty much 0 lines of code, apart from the configuration code, of course. And another nice part about Firehose, unlike Kinesis, it scales automatically, and you don't need to manage any shards, so it does all of it for you. And finally, it has a very big advantage of, again, not using a single line of code, but batching, compressing, transforming, and also converting your data to a different format. So it can convert your JSON data to a columnar format pretty much out of the box without you needing to write any code. So that's exactly what we do. So when the data is sent to Firehose, we convert the data from JSON to columnar Apache Parquet format, and after that, the data is batched and written to S3. So we basically achieved our first goal of loading data in columnar format to a data lake. So let's briefly compare the two services I talked to you about so far, Kinesis Streams and Firehose. Well, they are both fully managed services. Kinesis Streams is for streaming data. Firehose is for loading data to a destination. They have different data retention times, and the biggest difference is that Kinesis Streams, you need to scale it yourself. It scales manually, while Firehose scales automatically. And another big difference is that to consume the data from the Kinesis stream, you need to write custom consumers. With Firehose, you actually can't write any custom consumers. It will just load your data to a destination, but instead it provides you with batching, compression, and format conversion out of the box. And you also can write so-called transformer lambdas that will transform that data within your Firehose before delivering them to a destination. So the first goal was achieved. How about the second one, the enabling content personalization and near real-time analytics? Well, let's look at the second branch of our pipeline. And here we see another Kinesis service called Kinesis Analytics. And what Kinesis Data Analytics is, it's also a fully managed service, but this one is for running queries on your streaming data. So you can query it's data that is being streamed in near real time, and you can run joins, filters, aggregates over time-based or row-based windows. And it's a very useful service for things like near real-time fraud detection or anomaly detection, game scores, some online game scores, and so on and so forth. Kinesis Analytics can read or query the data from both Kinesis data streams and Kinesis Firehose, and it can send the data to another Kinesis stream, another Kinesis Firehose, or it can send it to a Lambda function, which pretty much means that you can do anything you want with that data afterwards. And the way we use it is that we use it for our content personalization that I talked in the beginning. So we want to show different images to different users based on what we know about them. And for that, we use a machine learning model called Contextual Bandit, which is an online unsupervised learning model, and it needs to be rewarded in order to learn. So we show you an image, a cover image, and if you decide to start watching that program, we take it as a good sign and we want to reward our model. And to do that, we need to analyze all that interaction events in real time, and we do that with Kinesis data analytics that is attached to a firehose and sends aggregates of events to a Lambda function, which then decides which model to reward with and how much. So we pretty much achieve the second goal with using this small function. And I must say that it's a very cheap part of our pipeline as well. It costs close to nothing. So a brief overview of what we were talking about so far. So we get the user interaction requests. They all come to our analytics collector. We filter them, we batch them, we send them to Kinesis data streams. And then we have a Lambda function that consumes our Kinesis stream. And based on the type of events it sees, it sends them to different firehoses. And their firehose takes care of batching and converting the data from JSON to a Parquet format, and then it writes it to an S3. And on the other hand, we have several Kinesis analytics applications that are attached to different firehoses, and they analyze data, streaming data in near real time, and then they send aggregates of that data to a Lambda function called reward router, which decides which machine learning model to reward with and how much. So that's pretty much it. So let's wrap up now with some of the gotchas and the lessons that we learned along the way. Of course, there were plenty, but I tried to choose just a couple of them to show you here. So first of all, Kinesis limits are per second. If you remember, it was 1 megabyte per second, 1,000 records per second. But CloudWatch metrics are per minute, so you get an aggregate metric over 1 minute time, and you never actually see what happens second to second basis in your CloudWatch metrics. And why is this important? Well, for example, your metric says that you have 2,000 incoming requests per minute. And can you exceed the throughput with that? It shouldn't be a big amount of records after all. But the answer is unfortunately yes, because, well, you might receive all that 2,000 requests in a very first second, and you can only, or the Kinesis stream can only process 1,000 of them, and the rest will be dropped. So the takeaway here is just don't blindly trust the CloudWatch metrics that tell you that everything is fine. You probably need to look deeper. And speaking about the limits, so this wonderful service, Kinesis Firehose, that scales endlessly and automatically. Or does it actually? So you read the documentation and it says it is a fully managed service that automatically scales to match the throughput of your data. And so far so good, but then you keep on reading, as you always should with the documentation, and you see this. When direct foot is configured, Firehose delivery stream is subject to following limits. And then they will go on telling you that the limits are soft limits, not hard limits, which means that you can increase them, but the bottom line is there are still going to be limits, and you need to be aware of that. And luckily nowadays there's even a metric that tells you how many of your records actually exceeded that limit. So you need to be careful with the limits. The other one is the timeouts. So all the API calls timeout, maybe because of network glitches or some other reasons. That's the norm. And also AWS SDK calls timeout correspondingly. The thing here is that by default, the timeout settings are set to 2 minutes. So your AWS SDK will actually wait for 2 minutes until the timeout happens, and only then retry your API call. And for example, in a Lambda function, that's a very long time. You probably end up timeouting your Lambda or spending enormous amount of money just on waiting. So you should always reconfigure the timeouts, and you should make them small. And this applies to all the AWS services. It's not Kinesis specific at all. And the last one, which is my favorite one, is it also applies to all the services and not Kinesis in particular, and that's the batch operations. So remember the put records API call, which allows you to write a batch of records to Kinesis stream. So what's wrong with this code? So if you get an error, you log an error. And if you don't see errors in your logs, then probably everything is fine, right? Well, of course, not exactly. And the problem is that you very rarely get an error from AWS SDK or from Kinesis SDK. Those are usually some temporary timeouts or network glitches, or maybe service was momentarily down. But those you don't even see because they are usually taken care by the retries, and you will never get any errors in your logs. Instead, what can happen is a thing called partial failure. And this is because all the batch operations in AWS, they are not atomic. So they are not either all fail or all succeeds. You can have a batch operation which returns your success code, but part of the records in that batch operation have failed, for example, because of throttling. Or actually, all of the records in that batch can fail, and you will still get a success code and never know about it. So what you should do instead is to look at the response that you get from Kinesis, and the response contains failed record count. And if that failed record count is anything other than 0, it means you had partial failures, and you need to do manual partial redelivery of your failed records. And related to that, you want to implement a smart way of retries and redeliveries. So usually, exponential backoff is used pretty often in all the retry circumstances. So you want to increase the delay before your next retry attempt exponentially. But it turns out that alone is not enough. And the problem is that your original request probably failed because of the exceeding the throughput of a stream or a shard. So your stream is probably already overwhelmed, and then you end up sending bursts of retry attempts to an already overwhelmed stream. So you just overwhelm it even more. And instead of that, you want to spread the retry attempts as uniformly as you can. And this is done by a very simple tactics of adding a random jitter to your retries. So just by adding a random component to your retry delay, you manage to spread the retry attempts more uniformly. And this is a very simple trick, but a very powerful one. And I, in particular, saw a decrease of failed records from something like several thousands per day to a steady 0 in the past couple of years, just because of adding this very, very simple thing. And once again, this applies to all AWS services, which use batch operations or any other retry, or where you need to retry things for yourself. And if you take anything out of this presentation, I would want it to be the batch operations and partial failures, and exponential retries jitter, and custom timeout, because those 3 things, they apply to all the AWS services, Kinesis, Dynamo, SQS, all of them. So very important things. So finally, to summarize some high-level lessons that we have learned, well, first, always learn about the service limits, because the matter of fact is there are always limits. They can be hard limits, they can be soft limits that you can increase with a support ticket, but they're still gonna be limits. And you need to know about them. And one of them you need to keep a very close eye on, as I said already, is the lambda concurrency limit, which has a huge blast radius. On the same note, always dive deep into the error handling of each service that you are using. Don't just assume things, because every service has a different flavor of handling errors. So always get familiar with those. And finally, to wrap up, once again, with words of Dr. Woggles, everything fails all the time, especially when we're speaking larger scale. So you better be well prepared, and you better fail fast. Thank you.
Hi, Anahit. Thank you so much for your talk.
Thank you.
I have a couple of questions for you.
Sure.
The first one is, how do you monitor an infrastructure that manages a data stream so fast, or how you observe your infrastructure?
All right. So we, of course, use CloudWatch metrics quite a lot, quite extensively. And then in addition to that, we have a Grafana monitoring. Actually, I show the screenshots in some of the first slides. So we have a Grafana monitor and a set of alarms set for different situations, which will let us know if something is wrong. But actually, the beauty of it is nothing is wrong nowadays. When we implemented the correct error handling in the situations I told you about, we haven't pretty much had any issues with that.
The second question is, how do you bisect your data on failures? Do you have any suggestion, advice, or tools about bisecting data?
So if you mean the things that I was telling about Lambda function when it fails, bisecting, it's actually inbuilt functionality of Lambda. You don't have to implement anything. So it's just a setting that you set that you, if in case of failure, you want to bisect your batch, and it will just split it in half and then send the two batches separately. And then if one of them fails, it will split that one and send them separately, and so on and so forth. So it's done for you, and it's very, very convenient that you don't really have to do anything. The only thing you need to remember, and that's an important point with Kinesis, is that it's at least once guarantee. So you might end up having, and you will end up having, a duplicate record in your stream. Because, for example, the retry attempts, and for example, splitting that same batch and retrying and retrying and retrying and things like that. So you need to take care of the fact that you might have duplicates in both Firehose and Kinesis, and your client needs to be kind of aware of that. So it needs to be done potentially.
Thanks. I have the last question. It is very detailed. It is, how do you select the partition key in Kinesis data stream? Do you use round-robin techniques, randomization, or the other techniques in general?
So as I said, in our case, we use the user ID, which is already randomized in a sense. But I think that the key here is to aim for randomness. It doesn't need to be that strictly random. It needs to be as close to random as possible in a sense. So you just need to look at the way your data is distributed in the shards, between the shards, and there are metrics for that, and then kind of make decisions based on that. But in our case, it's easy because it's kind of decided for us. We have the user ID, surrogate user ID, and that's what we use.
Thank you so much to be here with us, Anahit. Thank you.
Thank you
if there is any other question, I will let you know.
Sure. And you can always contact me on Twitter, for example, if you have any other questions. So I will be happy to try to help.
Thank you again to be here with us, and thank you again to Anahit from Solita. Thank you again. See you soon.